Good morning, Kip One Primary. This is Mr. Jennings. This is our science class. Just like we do in each science class, we're going to start off with our excellence mantra. Excellence mantra: respect what's mine, respect what's not. Respect our time, respect our thought. Work hard, try your best, take heart, shake the stress. Be kind and never give up. Rain or shine, I am enough. I'll read this one more time. We can say that all together. Respect what's mine, respect what's not. Respect our time, respect our thought. Work hard, try your best, take heart, shake the stress. Be kind and never give up. Rain or shine, I am enough. So last week we talked about being kind. Sorry, we talked about taking heart. This week we're going to be talking about shaking the stress. So shake the stress. Shake the stress means to get out of that funk. So whenever you're feeling like down, whenever you're not like feeling yourself or you're feeling sad, you need to shake that funk. You need to get out of that funk. This means that you can do things like believing in yourself. Whenever you're believing in yourself, you're trying to tell yourself positive things like we've been talking about, and getting out of that funky feeling and get into a more positive feeling. And then when you get back into that positive feeling, you can tune back into whatever you're doing. So sometimes, like we get stressed out from doing our work. While we're doing our work, it gets tough, which makes us stressed, which makes us sad, and will make us feel like we want to give up. But when you shake that funk, get that bad feeling off you, believing in yourself and telling yourself things like "I can do it," you can tune back into what you're doing and try your best to the best of your ability to get done with that product. Knowing that we all get stressed about something, but overcoming that stress shows your maturity. So it's okay. We all get stressed out about something. Your parents, your family members, your grandparents, everyone. We all get stressed out about something, but knowing how to cope, knowing how to understand and get away from that stress is the best thing that we can do. So we're gonna be singing a quick song that Mr. Jennings likes to sing to himself when he's trying to shake some stress. So we can all stand up. So I'll stand up. Yep, you, everyone stand up. So this is how the song goes, and then has some motions to it as well. So it goes shake, 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 shake the stress off, shake, 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 shake the stress off, shake, 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 shake the stress off. Love yourself and shake the stress off. Now you can do different things with it, and so we'll start over, and I'll put in maybe two or three different things. You can even make up your own things as you go whenever you need to shake that stress or whenever you're trying to help someone to shake that stress. Here we go. Shake, 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 shake the stress off. Shake, 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 shake the stress off. Shake, 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 shake the stress off. Love yourself and shake the stress off. Stump, 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 stomp the stress off. Stump, 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 stomp the stress off. Stump, 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 stomp the stress off. Love yourself and stump the stress off. Clap, 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 clap the stress off. Clap, 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 clap the stress off. Clap, 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 clap the stress off. Love yourself and clap the stress off. So that's something that I used to say, and some things that I still do and used to do in the classroom to shake those bad feelings off, shake that stress off, and tune back into whatever we're doing. There's different things that you can do to shake that stress off and get out of that funk and tune back into what you're doing. And that is shake the stress for this week. Okay, Kipster. So right now we're outside of our school. As you see our beautiful school in the background here. Know you guys miss it. Here is our football field. So glad to see you guys today. So what we're going to be doing in this part of our lesson is looking at our rain gauge. I'll take this off since I'm outside now. Cool. Remember, practice social distancing. Now that we are outside, we're going to be able to test and see how much rain has fell by our school. In order to do that, we're going to use our rain gauge. And so here is our rain gauge. What's going to happen is we're going to look at the millimeters. So this is the millimeters portion. We're going to be looking at the millimeters and see how much rain has fallen into our rain gauge. That's going to tell us how many millimeters of rain has fell around our school. Right now it is Wednesday. It's October 21st. It's about 9 a.m. I want to see how much rain has fallen throughout the day. So we're gonna put this down, we're gonna make a hypothesis and test the rain. I'll come back a couple of hours later to see how much rain has actually fallen. So first thing we're gonna do is stick our rain gauge into the ground. Put this down. Okay. So here I'm going to put my rain gauge inside. I'm simply going to leave the rain gauge here because it's going to measure the amount of rain that is falling. Again, right now it's 9 a.m. I'll put our millimeters measurement towards this way. It's 9 a.m. on Wednesday, October 21st. And we're going to be able to see how much rain has fallen at our school. So the grass is pretty wet here too. So we know it's already been raining. I wasn't able to get the rain from last night, but it's not a lot of rain, but it's been raining like a considerable amount. What we're gonna do is first use our observation notebooks. I'll write down a couple of things that I need to remember, like the date, Wednesday, 9 a.m. on October 21st. I'm also going to write down right now, there is no rain. No rain. As you look into the background, I can see that the sky is kind of gray. There's no sun. And right now, even though it's not raining, it's not really drizzling that much either, but there is a little bit of precipitation. Like I can feel like it's kind of wet in the air. It's also kind of foggy in some places. And fog also brings a form of precipitation because in the fog, it kind of drops down kind of droplets of rain as well. So I'm gonna put fog as well. These are just a couple of observations that I already see. And we're gonna be able to come back and see what does the sky look like, how much rain has fell into our rain gauge, what does the sky look like, is the sun out, and we'll be able to also see if our hypothesis is right. So you're gonna be able to make your own hypothesis down. I want everyone to write down how much rain do you think will fill up this rain gauge. For example, Mr. Jennings' hypothesis is it'll be 30 milliliters of rain, millimeters of rain. I seen that it's supposed to rain today and tomorrow, so I'm hoping that it gets to about 30 millimeters of rain, which is about that much rain. And we're gonna see if I'm right. Now, I might be wrong, I might be right. Either way, our hypothesis is just an educated guess, and we can always change our hypothesis at a different time. So make your hypothesis, write your hypothesis down, and when we come back, you'll be able to see if you were right, and you can give yourself a cheer, or do you need to change your hypothesis, which is totally right. That's what all great scientists do. All right, so we're gonna stop here, we're gonna leave our rain gauge here, and we'll see where the rain stops on our rain gauge. So we're back outside the school. However, it's Thursday. It's October 22nd. It's about 3 p.m. So it's time to look at our rain gauge. So looking at our rain gauge, sorry. Can I flip this thing? All right, so looking at our rain gauge, it's about 40 millimeters of water. Right now, thinking about last night, it rained last night and it was raining a lot yesterday, kind of from that drizzle. But now we see today, where's the sun at? Somewhere over there. It's kind of shiny, I can't really see on my phone. But it's more of a clear sky. It's not so gray out, the clouds are out. It's more of a beautiful day. So there isn't much rain happening right now, much precipitation happening, but we can see that over the night that it was raining, and we have 40 millimeters of rainfall from yesterday up until today. Is it going to be rainfall today? Probably not. We'll have to look at the Weather Channel and make a different observation tomorrow. But from today, we see the difference that it was from yesterday. All right, catch you guys later. And see what other observations we can make and what other things we can put inside of our observation notebook. Okay, this lesson is for 3rd and 4th graders. The name of this unit is still Weather and Climate. In this lesson, we're going to introduce line plots. Our lesson objectives. Kifters will be able to read and interpret line plot graphs. Kifters will also be able to make a line plot graph. In this unit, we have a new big question. Our new big question is, how can we predict the weather. Our new big question is, how can we predict the weather? I want to say all of our vocabulary words. We also have a new vocabulary word inside of our vocabulary word list. Pattern happens again and again. Seasons, spring, summer, fall, or winter. Precipitation, rain, snow, sleet, or hail. Temperature, how hot or cold. Measure, use a tool to find out how big, fast, or hot something is. Visualize means to make a movie in your mind. Meteorologist is a scientist who studies and predicts the weather. Weather, the temperature, wind, and precipitation outside. Observations or measurements is data. Data is observation or measurements. And our new vocabulary word in this lesson is graph. Everybody say graph. Graph is a way to show numbers that can help you see patterns. Review. In our last lesson, we learned that orangutans on Borneo and Sumatra Island have hot and rainy weather. On Borneo and Sumatra Island, they have hot and rainy weather. But we know that people are destroying their forest and they're trying to build palm oil trees to collect money. So we need to find another place that is hot and rainy. Last week, we looked at 3 islands, Ark, Creek, and Blue Island. We looked at 3 islands, Ark, Creek, and Blue Island. We found out which evidence cards were strong and which were weak. So we used strong evidence cards to figure out the right place for the orangutans to go. And we figured out that that was Blue Island. From the information or the evidence that we collected on Blue Island, we learned that the Blue Island was 95 degrees on one day. The Blue Island precipitation on one day, it was raining. That was a weaker card. Blue Island precipitation on one day, the rain filled 2 bowls, which was a strong evidence card. 95 degrees is also a strong evidence card. Blue Island precipitation on one day had 38 millimeters of rainfall, which is a strong evidence card. And finally, that orangutans live in some of the hottest and rainiest places on Earth, which was, we found out was kind of in between, but we kind of said that it was a strong evidence card. So we found out that from the information that we learned last week, that Blue Island seemed as if it was the best place for the orangutans to move to. So we're going to look at the new precipitation data and the data we use in our class argument, which is the one that we made last week. Do you still think the weather on Blue Island is most like the weather where orangutans live? So we found out that there was 95 degrees temperature, which is very hot. It had 38 millimeters of rainfall, which is pretty rainy. And we know that orangutans need to live somewhere that is hot and rainy. So from that information, it seemed that Blue Island was the best place for the orangutans to live. However, that was only one day. We didn't continuously look at a pattern to figure out if Blue Island was indeed the right place for the orangutans to go. So we have a new letter from the Wildlife Protection Organization. They sent them to us. We are their meteorologists. So here we have 2 meteorologists from Wildlife Protection Organization, and they have new island weather data for us. It says, thank you for sharing your scientific arguments. We have made more data from Blue Island, Ark, and Creek Island. The new data is attached for our review. So looking at our exit tickets, we sent out it to Wildlife Protection Organization, and they sent us some new data to look at. New temperature data from the islands. So Ark Island was 82 degrees, Blue Island was 83 degrees, and Creek Island is 101 degrees. Looking at this data, is Blue Island the hottest island? No. From here, it says Blue Island is only 83 degrees and Creek Island is 101 degrees. So the information that we received last week, it was the hottest day on one day, but we need to look at a pattern. We need to look at a pattern. Patterns are helpful because they help us look at something that happens over and over or continuously, and we're able to make a better hypothesis or assumption to where the orangutan should live. So here we know that one day that we looked at last week, even though we had strong evidence, it wasn't enough patterns to look at. The precipitation data from the islands. So looking at this precipitation data, it says Ark Island had 30 millimeters of rain, Blue Island had 0 millimeters of rain, and Creek Island had 15 millimeters of rain. So this is day 2. So looking at day 2, we seen that Blue Island wasn't as hot and it also had no rainfall. So right now, is Blue Island looking like the best island for the orangutans to live? No. So we need to look at more days to make a pattern. Right here is day 2. And now it looks like Blue Island just might not be that right island for orangutan. So we need to do some more observations and collect some more data. Think, pair, share. What does this new data show us? Look at this new precipitation data and the data we use in our class argument. Do you still think the weather on Blue Island is most like the weather where the orangutans live? The answer is no. On certain days, the Blue Island had, well, from we looked at last week, it was hotter, it had a higher temperature, and it had more rain. But from day 2, it is cooler than Creek Island, and it had less rainfall than Ark Island. So right now, it isn't looking like Blue Island is the best island to look at. One day of data didn't tell us which island will always be the hottest and the rainiest. We need to build the orangutan reserve on an island that has hot and rainy weather on many days, not just one day, but many days, because the orangutans need to live there for a long time. But how can we know the weather in the future? So I want you guys to take a second and think, how can we know the weather in the future? It's a word that I've continuously been saying. A pattern. We need to look at a pattern to look at a place where the orangutans can live for a long amount of time. When meteorologists predict the weather in the future, they look at patterns on weather data. A pattern is something that appears to be similar over and over again. So when it happens over and over again or continuously, that is a pattern. When it happens over and over again, that is a pattern. Very good. So we need to make predictions what will happen next. Over the next few lessons, we will look for patterns in temperature and precipitation data that will help us predict the weather. Big question, how can we predict the weather for a particular place and time? Again, we know that comes from this will be your exit ticket. How can we predict the weather from a particular place and time? It's going to be a pattern. We know that we predict weather in a certain place by looking at a pattern. So this is our Earth. This is the Borneo and Sumatra are these red dots here, and that shows where they are in the world. So Borneo and Sumatra are over here. These are the red dots. So this is Bentula precipitation data in January of 2016. So it shows every day in January, which is a pattern of the precipitation. So this is the rainfall, snow, sleet, or hail that it might have had. We know that this is more and better data to figure out something because it has a better pattern. Bentulu is a city inside of Borneo. Bentulu is a city inside of Borneo. So here we see that it started off with no rain. On the 3rd, it had 19 millimeters of rain. It had 3 more no rainy days, no precipitation. We have January 7th and 8th and 9th. We had little precipitation with 4, 5, and 1. 10th. So looking at this data, we see and we're able to make a pattern. We see that there's a lot of zeros. So it isn't a lot of rain in the city of Bentulu. This is now Bentulu's temperature data in Borneo. From the temperature, we can see that the temperature on each of these days goes from about 80 to 90 degrees, which all the way up into 92 degrees, which is pretty hot. The lowest we see here is, looking at this, we have 82 is the lowest on January 8th. The highest is 92, which we see about here on January 15th. So we see a range of data from 82 to 92 degrees, which goes from about hot to very hot. But that isn't the only way to collect data. Looking at that data, it wasn't very pleasing to look at, and it was a lot of information. It was a lot of data at once. We had to look at every day piece by piece. Today, we're going to be looking at a line plot. We're going to use a line plot to figure out some different data, and we're going to look at the different orangutan height. We're going to look at the female heights and the male heights of the orangutans. So looking at the female orangutans and the male orangutans, we're going to graph out where their heights are. So from here, we have the range of 119 to 133. Usually line plots start at 0. Well, sometimes they start at 0, but we started at 119 because that is the lowest amount of centimeters that I seen that the orangutans were. And the highest I seen was about 132. So I put it up to 133 just to make sure. These are the different orangutans here. Looking at these orangutans, we have the males and the females. Most of the males say male, and most of the females, it doesn't say female, but if it doesn't say male, it's going to be a female. And some of them do say female. So here we can see that. Oh, cool. So here we're going to look at the different heights of the females and males. So most of the women are on the left side, so the females are on the left side. So this side, this middle side, and this side, and all the males say male, and they're on the right side. So we have a female that's 120 centimeters, male is 126 meters. So I'll go back to our plot. So looking at a plot, this is how we're going to plot things out. And you're going to be able to do this at home. If you have a pencil and paper, if you can make the plot, you can send these in to me. And I'll be able to put you in our next lesson. So looking at our first one, female 120 centimeters. So what I do is I look for the number. It says 120 here. I'm going to put an X for one female, and she's 120 centimeters tall. And now I know that I have one female that is 120 centimeters in height. Next, I'm going to go down. Height 125 centimeters. So I'll go back. I'll go to 125, which is here. I'll put in another X here. We won't do all of the orangutans that I have. I have about 40. We're going to do about 20 of them and just plot out our line plot. Next, I have a female who is 121 centimeters. I go to 121, put an X here. I have one female that's 120, one female that's 121, one female that is 125 centimeters tall. Pretty easy. So next, I have a female that is 122 centimeters and 124. I can do them two at a time. It seems like I know that you guys are understanding it pretty quick. So I have one female that is 122 centimeters and one female that is 124 centimeters. So I look at 122 centimeters, I put her here. I have another female that is 124 centimeters, 124 centimeters tall, I put her here. Next, I have a female that is 121. And then this one doesn't say a height, so I'm gonna go down to 126. So I have 121 again. And then I also have 126, which is the tallest female so far. And then I have 122 centimeters again. So I'll go here. I'll go here. I'll go to 122 centimeters. Like I said, I have different orangutan females. I just think that you guys needed to see a couple of them or a couple of different orangutans' height plotted out on the graph. So basically this tells me that I have so far one female that is 120 centimeters, two females that are 121 centimeters, two females that are 122 centimeters, one female that is 124 centimeters, one female that is 125 centimeters, and one female that is 126 centimeters. This is what I see so far. Like I said, I have others, and if we have time or you want to see them to plot out your own graph, I can send them to you as well. So next, we're going to look at the male orangutan heights. For male, I have 126 and 131. So I go to 126. I go to 131. I have 132, 131. So I go back to 132. Well, I go to 132, then I go to 131. I can already see that from our information that the male orangutans are looking to be mostly taller than the female orangutans. I have 125. I have 129. I'll go to 125. I go to 129. Then I go to 130, 131. 130, another 131. Finally, I have a 129, and so I'll put him 29 centimeters tall. Here, I have one male orangutan that's 125, one male orangutan 126 centimeters tall, 129. I have two male orangutans that are 129 millimeters tall. Centimeters tall. I have one that is 130 centimeters tall. I have three males that we looked at that were 131 centimeters tall, and one male that is 132 centimeters tall. So looking at our data, so this is the data if I would have done all of the orangutans. So the females at the top, I had two females that I have 120 centimeters, four 121, three 122, one for 123, five for 124, one for 125, and the tallest female is 126 centimeters, and I have two of those. For the male, I have one that is 125, one male that is 125 centimeters, four male that are 126 centimeters, three male that are 127, none that are 128, three that are 129, two that are 130, four that are 131, and one that are 132 centimeters tall. What do we notice when we compare the height of the female orangutans to the height of the male orangutans? We can see something. We can see a pattern. The pattern is the male orangutans are mostly taller than the females, and the females are mostly shorter than the male orangutan. So from this graph or this line plot, we can make the assumption that male orangutans are taller than female orangutans most of the time. We can also see that we have one male orangutan that is shorter than two of the female orangutans, and he is the same height as one of the orangutans, one of the female orangutans. And then there are two female orangutans that are the same height as four of the male orangutans. And then the rest of the male orangutans are taller than all the rest of the females. Graph, this is one of our key vocabulary words, a way to show numbers that can help you see patterns. So a graph is a way to show numbers that, to show numbers that can help you see patterns. We were able to see a pattern looking at this graph, and it was easier to look at and more fun to do. Finally is our exit ticket. And our exit ticket will see how you guys are able to look at line plots and see if you are able to see what number has the most of something, or which ones was taller, the orangutan females or the orangutan males, and different other questions. I'll see you guys next week. I'm hoping that you'll be able to show me your different line plots later. Catch you guys later.